Hi, today we are going to focus on something called the free fall with air resistance, which will result in terminal velocity. This is one of the very difficult concept. Now, when something is released in air, and air has air resistance, now it will start to accelerate. Say, suppose if the ball is released from rest, alright, so the initial speed is 0, it will start to accelerate, right? It will start to accelerate. But because due to air resistance, the acceleration is decreasing. Now, it will reach a point where the speed of the ball will no longer increase but instead maintain at top speed, meaning that it will maintain at top speed. Alright, so this part here, it is what we call the acceleration, and this part here is what we call the zero acceleration, but because the speed is final and constant, we call this the terminal velocity or terminal speed. Now this acceleration here is very special. It's going faster but at a decreasing rate. Alright, and this is the part that can be a bit confusing. Now let's look at the graph of the speed time. Alright, it will not be a straight line because it's not falling in vacuum. So it will be a slope this way. Alright, so you can see that the speed is increasing, but you can see that the gradient is decreasing. So it shows that although it's increasing, it is a kind of acceleration, but the acceleration is decreasing, as you can see from the gradient or the slope. Alright, it's getting less and less steep. So if you see the gradient here, you can see that, alright, at first the acceleration is this much, the gradient, then the gradient is getting less and less and less and less and less, and finally the gradient or the acceleration is 0, and it maintains at this top speed, which we call the terminal velocity. So at this part here is called the terminal velocity. Now let's explain this motion in two parts. Alright, let's call it the first part here, which I'm going to highlight in one color. Alright, so this is the part. Alright, and then the second part in another color, and then this is the second part. Okay, this is the second part. So why does the acceleration decrease? Alright, why does the acceleration decrease? This part is because when the ball is falling down, the weight is constant. Alright, however, the upward air resistance force is not consistent. Alright, the air resistance force is not constant. In fact, okay, the key point for this is as the speed increase. Alright, this is the key point. Yeah? The air resistance also increase. It's just like when you ride bicycle, when you go faster, the air resistance going against you is also higher. And because of that, you can see that the weight minus the air resistance, which we call the resultant force, is decreasing because the resultant force is weight minus air resistance. So this one is increasing. Right? And because resultant force equals to mass times acceleration, therefore the acceleration will be decreasing, as you seen here. Now what about this part here? So this part you have to digest it. To me, this is the most critical part, and this is the part 2. Okay, why does it reach terminal velocity? So this is the second part. It's because the air resistance increase until it's exactly equals to the weight. Alright, when the air resistance is equal to the weight, the resultant force equals 0, and it will stop accelerating. Alright, it will stop accelerating because now there's no more resultant force. It will stop accelerating, air resistance force stop increasing, and it will continue at constant top speed. Alright, so this is about terminal velocity. Now if something drop in vacuum, alright, neglect air resistance, as mentioned in the previous chapter, it will be just like that without air resistance. Okay, so you just continue to go faster and faster and faster and faster at a rate of 9.8, or in O level is taken as 10 meter per second square. Alright, thank you.